Okay. So this problem uh, says use the node voltage method to find the branch I1 through I6. Test your solution for the branch currents by showing that the total power dissipated equals the total power developed. Cool. So I did a very similar problem to this. 2.24. I used it. I solved it using mesh analysis. So let's go back here. Yeah, I'm gonna use the universal method for this problem. So yeah, I'm gonna call this node here and make it ground. 125 volts. And this should be negative 125 volts. Call this V1, V2, and let me call this one V3. Okay, and we already have our KCL labeled, so I'm gonna go ahead and write the KCL. So it says, you know that I1 equals I4 plus I6, I4 equals I2 plus I5, right? And then we know I5 plus I6 equals I3. Okay. So yeah, these just to make sure. 2 and then, yeah. All right, and so so we have 6 variables for current, and then we have 2 variables for voltage. So in total, we should have 8 equations. Right, so I'm gonna go ahead and write the EFC. So let's start with I1. 1 should be 125. That's V1 over 1, right? I4 equals V1 minus V2 over 6. I2 equals V2 minus 0 over 2. I6 equals V1 minus V3 over 24. Oh, wait, no, we shouldn't have 8 equations. We should have 9. I didn't account for V3. So yeah, should have 9 equations. So we should have 6 EFCs, 3 KCL equations. Okay. I6, leaving off. I did I2, I5, V2 minus V3 over 12, and I3 equals to V3 minus 125 over 1. This would be V3 plus 125 over 1. Okay. Let's plug this to Maxima. Let's see, so we have 9 equations. Let's go ahead and write them. So I1 equals I4 plus I6. I4 equals I2 plus I5. 5 plus I6 equals I3. 1 equals 25 and 1 over 1. It's not even necessary. 2 equals 2 over 2. 5 equals V2 V3 12 4 equals V1 minus V2 over 6. 6 equals V1 minus V3 over 24. 23 equals say V3 plus 125. And then missing variables would be I1, I2, I3, I4, 5, I6, and then V1, V2, V1, V2, and V3. So here we get our equations. And they look like they're small. Oh, I'm gonna go ahead and just grab my calculator and plug this in and see what the what the decimal would be. The non-fraction form of this answer would be. So just do this. That would make it easier. Okay, so then I1 would be 23.76. I2 would be 5.328, which you can just say 33. I3 is equal to 18.43. 4 equals to 15.097. So we just round it. Say 15.10 amps. I5 is equal to 9.77. I6, well, 9.769, 9.77, and then I6, 6, 7, 5, 5, 6, 3 would be 8.658. So you'd say round it and say 8.66. Right. So yeah. So our V3 also have a negative voltage. Okay. So yeah. So now part B of this question is asking us to find that the total power dissipated equals to the total power developed. So do this part here, B. So let's start with the 1 ohm resistor. Right, so we know the power formula. It's power times V equals I squared equals V squared over R. So we'll use the current and then just, or what am I doing? That's not written right. Current squared. You guys get the point. Handwriting is not that great, especially with this. All right, so the 1 ohm resistor, so 1 squared times, or we know I1 is 23.76 squared times 1. I'm gonna go with the 6 ohm resistor. So we know I4 15.10 squared times 6. We're gonna go with the 24 ohm. You know, I6 is 8.66 squared times 24. And you got a 2 ohm resistor. I'm gonna call this power of 1 ohm resistor A, and then I'm gonna call this one B. But let's keep going. So current I2, 2 is 5.33 squared times 2, and power across the 12 ohm dissipated. I5 is 9.77 squared times 12, and we got our 1 ohm B. You know, I3 is 18.43 squared times 1. Cool. And then I'll do power developed with orange. So power developed by 125 volt source A. I'm gonna say I1 time, or I'm just gonna say I times V. So I, we know current I1 23.76 times 125, then power 125 volt B is I3, so I3 is 18.43 times 125. Yeah. Yeah. Let's see. Okay, so let's plug this into our calculator. 564.5376. point squared times 12. Maybe total for this would be uh, so our total power developed or dissipated would be, I think I'm doing something wrong. Maybe I have to round. Yeah, let me take these out, make this a 2. Five, make this a 4. Yeah, make that one a 7. Round to to 2 decimals. That's something important to do. Yeah, so let's try that. So and this last one, top one. Okay, so 5, 6, 4 plus 1. What am I doing wrong? They're almost close. They're all getting. Five, 2, 7, 4.42. There's something off here. Mhm. There, I could go with these exact values. I think actually that might make the difference here. Let's go ahead and redo this. I apologize. I just want to make the answers exact. Yeah. So I1. Okay. I5. And for the power developed, okay. So I'm gonna go ahead and plug this in. One. I don't even know if I should write all this, or how much I should round it. I'm gonna plug everything in, write the whole answer out. Two, 9, 8. Okay. I think this should be right. I think the decimal is what throws off the answer here, since they can go really small. Okay, so P total for developed maybe 09, and then P this is gonna be cool. Yeah, so these are the same. Um, rounding off in this type of problem is a little rounding off the power for these, which is a little confusing, but so you gotta be careful with that. Not commit the sin, or I did, and make the video longer than what it should have. And yeah, so 0986. So yeah, these power dissipated equals power developed. So there's our answer.